Hi, my name is Anyier, and my team members are Sara and Ahmed. Our Fermi question is, how many soccer balls would it take to fill up an entire classroom on campus? We have chosen this question because it will widen and expand our imagination and knowledge on how to estimate and measure the areas and volumes of different shapes, which is quite an impressive skill to master. And it can help us in a real-life problem to estimate the capacity of rooms and stores we can fully use. What is the average diameter size of the soccer ball? We assume that the average diameter of a soccer ball is similar to the length from the tip of the middle finger to the bottom of your thumb. We assume this because when you grip a soccer ball with one hand, you can cover almost half the soccer ball to ensure your grip. The average diameter of a soccer ball is 22 centimeters. We assume that all the soccer balls are purchased in the same size and to ensure our calculation is accurate.
So our third question is, does the way how the balls organize on board will make a difference? And yes, we assume it will make a difference, as it is planned to place the ball on top of each other vertically. This will save rooms area, as the gaps between the ball will be minimized. And by dividing the volume of a room by the volume of a single ball, we will get the maximum possible number of balls that can fit the room. So moving on to our fourth question, which is, what is the shape of the room and is it empty? We assume the room have a cubic shape, but firstly, we need to consider that we will measure an empty room. So remove everything on the room. After that, we will figure out what might give us an extra area in the room. For example, does the room have windows? If yes, how many windows the room have? So after planning, we went to the room and we removed tables and chairs, and we found 3 windows. We estimated windows length is 20 inches, approximately 60 centimeters, and the height is 35 inches, approximately 89 centimeters, and the width is 1.5 inches, approximately 3 centimeters. And after that, we measured the room dimension. Anyier said her foot size is 12 inches, so we used that information to measure the width and the length of the room. We surprisingly found that both length and width of the room almost have the same measurement, which is 275 inches, approximately 7 meters. And after that, in order to estimate the height, we used the whiteboard in order to have more precise estimation. So firstly, we estimated how many whiteboards can fit the wall, and we found that it is 3 whiteboards. Second step was estimating the width of the whiteboard, which was approximately 2.4 meters. So the height of the room was 2.4 multiplied by 3, which is approximately 7 meters. So overall, the room is approximately have a cubic shape with a volume of 343 cubic meters. And because the window's volume is small comparing to the room volume, as it is 0.096, we discard it. So finally, the overall room area is 343 cubic meters.
Based on previous question, I will identify variables we use in the calculation part. We have 2 objects to identify on the tutorial room and the soccer ball. First, for the variable, the room is cubic shape, so the height, the length, the width, h, l, w, respectively equal to 7 meters. The volume of the room is V. Second, for the variables of the soccer ball, diameter d equal to 22 centimeter, equal to 0.22 meter. So the radius diameter is divided by 2 or equal to 0.11 meter. The volume of one soccer ball is 3 balls. Balls can fill up the tutorial room. We need the following. The volume of the room equal to height times width times length equal to 343 meter cube. The volume of the soccer ball equal to 4/3 pi r cubed equal to 5.475 times 10 power minus 3 meter cubed, and we roll equal to 6 times 10 power minus 3 meter cubed. Finally, the number of the ball equal to room's volume divided by ball's volume equal to 57,166.67, and we roll to 57,166.
The answer from our Fermi question seems reasonable as the values we used are estimated and were explained in the fundamental questions. Moreover, we round the number of balls from 61,469.53 to 61,469 because there is no 0.53 of a ball, and if we round up, the extra ball will not fit in the room. Another method we can use to test this Fermi question is placing the soccer balls in square boxes that have the same dimensions as the diameter of the soccer ball. There is no way to look up the answer of our Fermi question, rather we would have to test it in a similar size room or one that is a bit smaller and round as much as we can. Thank you for watching. I hope this was interesting and we hope to apply this in the future. Thank you.